selectivity of EDTA as a titrant. Selectivity of EDTA as a titrant. Okay, so here, as we know that EDTA forms a stable complex with the most of the polyvalent cation. Okay, and therefore, at a single time, if it forms the stable a complex with the many cations, and if you are interested to find out the concentration of only one cation out of that different cation solution, okay, so that will become very difficult. That will become very difficult. Okay, and hence to perform analysis, okay, we need to do the successive titration. Okay, and that becomes very complicated. So what are the things over there that can help us to increase the selectivity of EDTA as a titrant for the analysis of particular element from the solution of the different metal ions? Okay, so what are that things that we are going to see in this lecture? Okay, and after that we'll see what are the advantages of using EDTA as a titrant and what are the limitations of using EDTA as a titrant. I think limitation, you are just came to know that it forms a complex with multiple ions, and that is what it's a limitation. So how we have to overcome that, we'll see with the help of example in next few slides. So see, factors or the methods used to enhance the selectivity of EDTA titrant. EDTA titrant, त्याची तुम्ही सिलेक्टिव्हिटी कशी वाढवाल, है ना, की त्या ठिकाणी 5-6 मेटल आयन्स आहेत एका पाण्यामध्ये. पाण्याचं अनालिसिस करताय, 5-6 मेटल आयन आहेत त्याच्यामध्ये. कॅल्शियम आहे, मॅग्नेशियम आहे, लेड आहे आणि काही असतील त्याच्यामध्ये, कॉपर आहे. तर फक्त तुम्हाला कॅल्शियमचं अनालिसिस करायचं आहे, तर तुम्ही फक्त कॅल्शियमचं कसं करू शकता? EDTAचं टायट्रेशनला घेतलं तर सर्वांबरोबरच तो कॉम्प्लेक्स तयार करतोय. मग एंड पॉइंट कसा कळणार आम्हाला? How we can do this? So see, these are the methods by which we can increase the selectivity, and we are making that EDTA to react with particular metal ion only. Okay, so how situation happens? See, first chemical separation. Chemical separation. So what we are doing here in this method, we are going to separate a desired species from the other components, and that desired species we will titrate with the EDTA or react with the EDTA. Okay, and how we can separate? We can use a precipitation or a chromatographic technique for the separation of that species from the rest of the species, and by the titration we can find out the concentration of that particular species with the help of EDTA. In another method, next is a control of acidity and pH control, that is or pH control you can say. So what happens? Different metal ions forms the complex with the EDTA at a particular pH, and that needs to reach that pH to form the complex. See what happens here. One example what they are mentioning here. So calcium can be determined in presence of magnesium, okay, in strongly alkaline solution using peroxide as an indicator at a pH. इथे चुकलेला आहे, 2 म्हणजे तो ऍसिडिक झाला आणि इकडे स्ट्रॉंगली अल्कलाइन म्हणतोय तो. Here it should be 12. Here it should be 12. Okay. So at the pH 12. Okay. Similarly, trivalent ions like Bi3+, Fe3+ may be determined in the solution containing several bivalent metal ions. Okay. How it is possible? You just control the pH. You just control the pH that is available in the literature. At which pH we can find out the calcium concentration, at which pH we can find out the magnesium concentration, or to find out the trivalent metal ion, what pH we can use. Okay, that is there in the literature, and we have to maintain that particular pH with the help of buffer solution. Okay, next one is the masking, use of masking. पहिले काय बघितलं आपण? केमिकल सेपरेशन ने आपण सिलेक्टिव्हिटी वाढवू शकतो EDTA ची as a titrant. Then control of pH, त्या ठिकाणी आपण त्याची हे वाढवू शकतो सिलेक्टिव्हिटी. त्यानंतर use of masking agent. Okay, it is a process in which substance without a physical separation of it or it's a reaction product is so transformed that it ceases to enter into the reaction. Don't get confused over here. काय करतो आपण की ज्याचं अनालिसिस करायचं नाहीये त्याला आपण मास्किंग करतोय. त्याचं काय करतोय? मास्किंग करतोय. आणि ज्याचं अनालिसिस करायचं आहे त्याला मास्क करत नाही. मास्क म्हणजे थोडक्यात कव्हर करतोय, प्रोटेक्ट करतोय. ज्यांचं अनालिसिस करायचं नाही ते प्रोटेक्ट केले, आणि ज्याचा अनालिसिस करायचं तो फ्री ठेवलेला आहे सोल्युशन मध्ये, है ना. बघा, an effective masking agent for EDTA titration is a cyanide ion. कसा वापरतो बघा तो. This forms a stable complex with the cations of CD, zinc, mercury, copper, cobalt, nickel, silver, and the platinum metal. Okay, but not with the alkaline earth metals like manganese and lead. Okay, the cyanide can form the complex with this one, but that cannot complex with the manganese and lead. Okay, thus it is possible to determine the cations like calcium, magnesium, lead, manganese in presence of other cations with the help of masking agent like a potassium cyanide. We can detect these metals. We can detect this metal, calcium, magnesium, lead, manganese, in presence of all other metals when there will be the cadmium, zinc, mercury, copper, cobalt, nickel, silver. Okay, आणि त्याच्यामध्ये हा जर यातला एखादा असेल तर we can use a potassium cyanide over there and we can detect a particular element. We can detect particular element. This is what the use of masking agent. Okay, use of masking agent म्हणजे बाकीचे जे आहे त्यांची रिॲक्ट होण्याची कॅपॅसिटी स्टॉप करून टाकली आणि फक्त जो पाहिजे तोच त्या ठिकाणी रिॲक्ट होतो मास्किंग मध्ये. ओके, so demasking is also there. Now how demasking works? If you have a mixture of calcium and magnesium with you, this is what we are performing in the practical. Okay, what we are doing, we are doing the analysis of calcium at the pH 12, at the pH 12. Okay, and now for the next time what we do, we take that pH to the 9, we take that pH to the 9, or where we can analyze the magnesium. We can analyze the magnesium. How we can do this? See, if the pH is lower to about 9, after the calcium estimation, magnesium hydroxide dissolves and magnesium can be titrated against EDTA. Okay, formaldehyde demasks zinc from the complex. Okay, so इथे एक त्यांनी demasking चं एक उदाहरण दिलं बघा. Zinc cyanide आहे, when that is reacted with the 4 molecule of formaldehyde, that is acidic solution, zinc will get separated. Here is the formation of this specimen. It should be the CN. Okay, similarly kinetic masking is there. Kinetic masking, most of the metal EDTA complexes are formed practically instantaneously. A few are formed slowly. जे फटकन तयार होतात कॉम्प्लेक्सेस मीन्स इन्स्टंट, सी हियर इट इज इंस्टंटेनियसली. ओके, माझे थोडंसं जास्त बडबड केल्यामुळे स्लिप ऑफ टंग होते. इंस्टंटेनियसली काय होतंय की म्हणजे क्विकली ज्यावेळेस प्रॅक्टिकल तुम्ही स्टार्ट केले आणि क्विकली ज्याचे कॉम्प्लेक्स तयार होतात EDTA बरोबर ते डिटेक्ट करून घ्यायचे आहे, आणि बाकीचे स्लोली कॉम्प्लेक्स तयार होतात ते तुम्ही काय करू शकता, अवॉइड करू शकता. जसा Cr3+ complex with the EDTA at a room temperature only to slight extent, even after the few days. It takes a few days to form a complex. But Fe3+ forms complex quickly or instantaneously. Okay, to form or to we can analyze the Fe3+ very quickly from the solution of Fe3+ and chromium 3+. Okay, so these are what the 5 method by which we can increase the selectivity. First is a chemical separation, second is a control of pH, third is the use of masking agent, then demasking agent, then kinetic masking. All these are the method by which we can increase the selectivity of EDTA as a titrant. Then what are its advantages of EDTA? What are the advantages of EDTA to use as a titrant? It forms a stable complex. Okay, that formation occurs in a single step. It gives sharp change in the produces sharp change in the metal ion concentration at the equivalence point. Metal EDTA complexes are water soluble. Okay, and EDTA forms 1:1 complex with all metal. This is very important. म्हणजे एक EDTA मॉलिक्यूल हा एकच मेटलला पकडून ठेवतो किंवा त्याच्याबरोबर रिॲक्ट होतो. हे काय त्याचे ऍडव्हांटेजेस असल्यामुळे आपण तो त्या ठिकाणी यूज करतो. मग लिमिटेशन काय होतात? सी, वी नीड टू कॅरी आउट द titration at a relatively high pH, okay, which may leads to the difficulty due to hydrolysis of certain metal ions. त्या metal ions काय होतं, metal hydroxide तयार होऊन जातो, and in that case that hydroxides are insoluble in the water, okay, or the basic salts, which may complete with the complexation. So that creates the problem. Hydroxide झाली, if that metal ion is not free for you to react with the EDTA now, and then you can detect the metal ion. जेव्हा तो EDTA बरोबर रिएक्शन दाखवेल, तो EDTA बरोबर रिएक्ट व्हायच्या ऐवजी तिकडे त्याने हायड्रॉक्साइड करून ठेवलाय मेटल आयनने. कसं काय रिएक्ट होईल? We cannot analyze. This is what the trouble we may face during the titration. Okay, as it forms, EDTA forms stable complex with the most of the cation. Okay, the reagent lacks the selectivity. इथे selectivityचा प्रॉब्लेम आपण फेस करतो आहे. आणि म्हणून काय होतं की टू फाइंड आउट द सिंगल मेटल आयन फ्रॉम द मिक्सचर ऑफ मेटल आयन्स, we need to carry out the successive titrations. Okay, so by the separation and following different methods, like to increase the selectivity, this is what the limitation of this technique is. So these are the things which are associated with the metal EDTA titration. Okay, so that comes in the complexometric titration. Complexometric titration. Okay, after that we will go to the topic types of EDTA titration in the next lecture. Thank you.